So as I was saying, it would be amiss of me if I talk about basic algebra without introducing you at least to what we call simple equations. And when I introduce this to you, we'll talk a little about simple inequalities, right? And then we'll conclude the evening with something called quadratic equations and how we go about solving them, right? So let's start with simple equation. What's a simple equation really? Well, it's simply um, an equation with one unknown, right? And the unknown can take on only one value, right? So let's say you have something like this. You're asked to solve something like this. Solve x plus 4 equal minus 1. That's a simple equation, right? The unknown is the x, and that can only have one value, right? So that's what a simple equation is. And a good comparison to a simple equation is like a scale, the scale. And therefore, to maintain balance, what you do to one side, you must do to the other side, right? So your purpose here, when they say solve that equation, what they basically mean, find the value of x. That's what they mean, right? So we see here, there's a 4 here. So we want x. So what we need to do is get rid of this 4. So since you have x plus 4, what we could do is subtract 4 from both sides, right? So we just x plus 4 minus 4. So this here is going to become 0, right? You're left with x equal negative 5. And that's your solution. Simple as that. There are some people who they have this what called shortcut, right? And what they do, they take okay, you have the x plus 4 equal minus 1, and they'll tell you to take over positive 4, and it becomes minus 4, right? So x equal minus 1 minus 4. No harm, no harm. It's just a shortcut. But this process of saying take over 4 and becomes minus, that's not a mathematical operation, right? That's just a shortcut that people have been using for quite a while. And, nobody objects to it. And it has become like acceptable in mathematics, But what you're really doing is that you're subtracting 4 from both sides. And like I said, it's like a scale. Once I do the same thing to both sides, I have not, in effect, affect the balance, right? I have not changed the balance of the equation, right? Of course, equations are going to get more complicated as we go on, right? Let's say, all right, let's get more complicated now. Let's solve something like this. Solve uh, x minus 1 equal minus 3. Now we want to basically find what the value of x is. So we got to get rid of this minus 1, right? What do? We add 1 to that side and do the same thing over here. What we do to one side, we do to the other side, right? So we add positive 1 to both sides, right? Right. This is EN, right? So we end up with, well, these two are going to become 0 and x equal minus 2. Easy, right? Easy?
Pretty easy, sir.
All right, what do we have this? But this now. So some people, some people, let's say, all right, let's subtract 3 from both sides. So take 3 minus x, you can put a minus 3 here, 4 minus 3, good. So this 3 minus that 3 becomes 0, and you're left with minus x equal to 4 minus 3 equal 1. But we're not done there because we want x and not minus x. In our next step, we can either, okay, well, all right, let me write a statement here. Subtract 3 from both sides, right? Leaving out the e each time, yeah. And that's what we're doing here. Some people might not write it like this. They'll write it like this. 3 minus 3, they'll subtract the 3 right there, and then put a minus x equal 4 minus 3, right? Let me move this a little. Okay. Yeah. So you'll go with 4 minus 3, right? Same thing. It's the same thing, right? Just written a different way. I choose to put it back here. They might choose to put it there, right? Good. So now we have this, but we want x and not minus x. So what we'll do now, multiply, spell the word around here. Multiply both sides by 1. Sorry, minus 1. So you're left with this now. Minus x multiply by minus 1 equal 1 multiplied by minus 1. This here becomes x, right? A negative by a negative gives you a positive, and this becomes minus 1. You could also have divided both sides by minus 1. You could have done that too, right? Another approach, right? Another approach is this. Another approach is this. Some people do this. Add x to both sides. So you get 3 minus x plus x equal 4 plus x. So these two will become 0, and you're left with 3 equal to 4 plus x, right? Now this resembles what you were dealing with all the time. You can write it back like this. X plus 4 equals 3, right? Same thing. So now you can solve by subtracting 4 from both sides, right? So subtract 4 from both sides. Oh, maybe I should put a statement here. Add x to both sides, right? That's what we did there. We got that, right? And we just rewrite this, and that's what we get. And now we subtract 4 from both sides. You get x plus 4 minus 4 equal 3 minus 4 minus 4. So your answer coming up here, these two are going to become 0. You're left with x equal minus 1. Right? So that's an alternative approach. Of course, there's a shortcut, right? There's a shortcut that people like to do, and this is what they do. I'll show you in a moment. People like to do this. They take the minus x over here, and they take the 4 over there, right? And they change the sign. So you have 3, it was positive 4 here. So when it goes over, it becomes negative, equal to, and you the minus x here, when you bring it over here, you get positive x, right? So you end up with minus 1 equal to x, which is the same as x equal minus 1, right? Those arrows do not indicate a mathematical operation. It's just a shortcut that people use, and it has become acceptable now. But it's important you understand previous approaches, because that is a mathematical approach, right? It's a systematic approach that works, right? While this one gives you the answer, and so it is important you understand, well, that you don't violate any property of mathematics, right? Like these arrows about taking this over and that over, those are not mathematical operations, right? There are those who would frown upon this shortcut. I don't have a problem. Then you have equations like this now. Let's say you have an equation, okay, 2x equal to, let's say 4, right? I have to solve something like this. Well, all you have to do is divide both sides by 2. So you divide, what am I doing here? Both sides by 2. So you have 2x over 2 equal to 4 over 2, cancel this, one, cancel this, cancel that, you end up with x equal to 2. Very easy, huh? Following so far?
Yes, sir.
Great. So let's get a little more complicated. Let's get something like this now. 2x minus 1 equal to 5. Right? So we have to solve something like this now. Well, first we might want to isolate the term involving the x. So we want to get rid of this minus 1. So what do? We simply add 1 to both sides, right? You want me to write that here? Add positive 1 to both sides, right? So these two are going to become 0. You end up with 2x equal to 6. And then your next step, divide both sides by 2, right? You got 2x over 2 equal 6 over 2. So these two are going to cancel out. And you're left with x equal to 3. Was this one difficult? Hmm? Not hearing you. Did you follow this one?
No, sir. Yes, sir.
Okay. Let's get a little more complicated. Let's say you want to solve, all right, let's go with 2x minus 1 equal to x plus, let's go with 9. So this one, you got x both sides now, right? So you could do it a long way, right? Like, okay, as I was doing it, do it in pieces. And then I'll show you the shortcut where a lot of people employ it. And it has become acceptable, So what we could do, we could get all the x's on one side. So what we need to do, we need to subtract x from both sides to get rid of this x, right? Subtract x from both sides, right? So you get 2x. I'm going to take the x from here, minus 1, equal to x minus x plus 9. So this becomes x. This becomes minus 1. That becomes 9, right? Our next step is to get this one over here now, right? So we got x minus x, right? So I probably add 1 to both sides, right? So x minus 1 plus 1 equal to 9 plus 1, right? So this becomes 0. You end up with x equal to 10, right? What some people do, they do a shortcut. Let me show you that quick shortcut that they do. Anybody taking notes if I erase this? What are you taking notes? Important that you take notes, you know.
Yes, sir.
Don't sit
Yes, sir.
passively. I can take notes. There might be something I say or write that, huh? All right. What's going on? Yeah, let me just show you that shortcut. And this is what some people do. They take the minus 1 from here, bring it over here, and that minus 1 becomes a plus 1. And you take this over here, and it becomes minus x, right? So you end up with 2x minus x equal positive 1 plus 9, right? Therefore, x equal to 10. So that's a shortcut a lot of people employ. And, you know, people would accept it, right? Rather than doing that mathematical approach where I showed you step by step, right? So this is acceptable, no problem. Watching it good? You ever see it before?
Yes, sir.
Okay, all right, good. So let's get a little more complicated. What if you have something like this now? Look at that. You have to solve that, right? Give me a second. Let me just this one close out. 1 second. So what do you think we do here? Any ideas from you? What could we do here?
You apply BODMAS?
BODMAS, okay. So what do you do? How do you apply it?
You solve the bracket first, which is x plus 1.
Okay, you remove the bracket using the distributive law, you call it. Now, you
Yeah.
did say BODMAS, and I'm happy you said that. Because according to BODMAS, and some people might be tempted to subtract this 2 from the 3, but BODMAS is telling you shouldn't do subtraction first. Subtraction is way down the end, right? So what you should do is there's a multiplication sign there, even though we don't normally write it, right? So we remove the bracket first. So that's what we do. Minus, okay, minus 2 by x will give you minus 2x. Minus 2 by positive 1 will give you minus 2 equal to 4. So I'm happy that you said to use the distributive law to remove the bracket first, right? Because That's basically a multiplication there. So what you do, remember multiplication comes well before subtraction. And that is why I remove the bracket first. So you can now simplify this part, 3 minus this 2. So you end up with 1 minus 2x equal to 4, okay? And if we can do the shortcut now, take this over here and take this over here. So we end up with 1 minus 4 equal to positive 2x. 1 minus 4 is 3. Sorry, minus 3 equal to 2x. And then you divide both sides by 2 now. Minus 3 divided by 2 equal to 2x divided by 2. So that means that minus 1.5 is equal to x, or you can write it as x equal minus 1.5. This one look complicated?
Little bit.
Yes, sir.
Okay, all right. So yeah, that's how they are now, right? Things can get a little more complicated, right? So let's take another one. Let's solve, let's take one more like that. 2 bracket x plus 1 equal 3 bracket x minus 1. Look at that. Right? So again, you just remove the brackets. You get 2x plus 2. Right? You multiply this number 2 here by everything in the bracket. That's the distributive law. Equal to 3 by x is 3x. 3 by minus 1 is minus 3. See? And then you can do a quick shortcut if you want. You bring this over here and you take that over there, right? Over there. And you end up with minus, this minus 3 when it goes over become a positive 3 plus 2 equal to 3x minus 2x. So 5 then is equals to x, right? Or you can write that as x equals 5. Complicated?
No, sir. Get it now.
Getting it. Very good. Right. Let's do one maybe with some fractions. All right, let's go with a simple one. Solve x over 6 is equals to 3. Something like that, right? So what we could do here, we want to get rid of this 6. So what do? We don't divide this time, we multiply by 6 over here, and then we do the same over here, right? But this 6 and this 6 cancels out, and you're left with x equal 18. Some people do something they call cross multiplication, right? It's not mathematical really, right? Or there's no operation called cross multiplying in mathematics, but we do accept it. We put a 3 over the 1 and we do this, right? And arithmetically, right, it is correct. You do get the right answer then. So 1 by x, you get x. 6 by 3, you get 18, and you're done there, right? And it's acceptable. So what do you question what you're doing? All right, let's try another one. What about 3 over x equal to, let's say, 2? Right? So there are two approaches to this. What we could do, multiply both sides by x. Let's go with that. So we end up with and you're left, well, these two will cancel out, right? Because like x over 1. And you end up with 3 is equals to 2x. And now you divide both sides. Divide by 2, right? So let's go with that. You get 3 over 2 equal to 2x over 2. These two will cancel. We end up with x equal 3 over 2, right? Which is 1/2. Alternatively, some people do this. They do the cross multiplying thing. 3 over 1, 3 over x equal to 2 over 1, right? So they do this and they do that. And you end up with 3 is equals to 2x. And then you divide both sides by 2, you get 3 over 2 equal to x, right? You can write that back as x equal 3 over 2, or you can change that back to mixed numbers and say 1/2, right? X equal 1/2. How does this one look?
Bit complicated.
Okay.
The first part of it is a bit complicated, but the other side I can do it that way.
You can do this. You like this cross multiplication thing?
Yeah, because it's
Alright.
much more easier and quicker.
All right. It works, right? But it's good to know, in effect, what you're doing, the mathematics behind it, right? Good to understand that. All right. Then you can have equations that involve fractions. Let's say you have this now. Solve, okay, half x plus 1. Sorry, that's a quarter x plus 1 equal to 2. Look at that. Right? So what are you going to do here now? Well, you can take the 1 over here and subtract, right? Subtract both sides. Subtract 1 from both sides, right? And you get what? A quarter x plus 1 minus 1 equal 2 minus 1. Right? So you get a quarter x equal to 1. So you can do several things here. You could take this quarter down and divide. So divide both sides by a quarter. So a quarter x over a quarter equal to 1 divided by a quarter, right? So these two are going to cancel. You get x equal, I'll write this as 1 divided by a quarter, which is 1 multiplied by 4, right? Or 4 over 1, which is 4. So x equal 4. Think you follow this one?
Yeah, this one I heard, sir.
All right, all right. It can get complicated. Let me show you a very complicated one. So you get 1/3 x minus 1 equal to a quarter x plus 2. Right? And there are different approaches that you can use, right? I'll show you maybe 2 of them. I can get these 2 x's together, so I can do this. Minus a quarter x equal to, bring this minus 1 over here, right? So we take this over here, and you take that over there, right? So you end up with 1 plus 2. Then what we could do here is add these two up, right? Sorry, subtract them, right? Take the x outside, And you will have 1/3 minus a quarter, right? And you know, it'll do the usual thing. Find your LCM. 12, so that'll be 4 minus 3, right? So that'll be what? What's this? 1 over 12? 1 over 12, I'll put the x behind, equal 3, right? So I can now multiply both sides by 12. Multiply both sides by, you can do it by 12, and you have 1 multiply by 12 equal 3 multiplied by 12. You can do that, and you will get, well, this and that will cancel out. You know, x equal 36. Or you can do this, you can divide both sides by 1/12, right? Or divide both sides by 1 over 12, right? So you get 1 over 12x divided by 1 over 12 equals to 3 divided by 1 over 12, right? So these two are going to go, and you will end up with x equal, well, I'll write this as 3 divided by 1 over 12, which is 3 multiplied by 12 over 1, right? Which is 36, right? So x equal 36. Whichever approach you like. So that's how complicated it can get. Even more complicated than that. I can't cover every single thing on equations, right? Good. So let's touch a little bit on something called simple inequalities. Simple inequality, right? How do we handle those now? So there's a simple rule to solving simple inequalities, right? And this is what you do. So simple inequalities, you solve them exactly the way you would solve simple equations. The only exception, there's one exception. And what's that? If you multiply or divide throughout by a negative number, reverse the inequality sign, right? That's a little bit an additional something you must remember. And I'll illustrate just now. You get this rule? So you solve simple inequalities exactly the same way. I didn't get that.
Please go it over once more.
Yeah, okay, that's what I'm doing. So you solve, write this down if you want to write it down. Solve simple inequalities the same way you solve simple equations. Only exception is that if you multiply or divide throughout by a negative number, reverse the inequality sign. That's the only little thing you have to do. I'll illustrate with examples in a moment. Good. Let's do a few examples to illustrate what I'm talking about. So let's say you have, all right, 3 minus x is greater than 4. And you have to solve, right? Solve. So, all right, if I am to take 3 from both sides, right? So I'll end up with, I'll skip the step of showing you all of that, right? Take 3 from both sides, you end up with minus x is greater than 1, right? So if I were to take 3 from both sides, this 3 will disappear, 4 will become 1. So we now have negative x here is greater than 1. We don't want that, we want x. So what we're going to do, we're going to multiply both sides, minus x, multiply it by minus 1. That will make it positive x. And according to the rule I just told you, when you do that, you have to change this around. And then you multiply over here by minus 1 as well. So now you have x is less than minus 1. Right? And to show you that that reversal of the inequality sign is necessary, just think about it. All right, watch. According to this solution, right? According to this solution, x is less than minus 1. So x could be, let's say, minus 2. Let's try minus 2 in this inequality and see what happens. So you get 3 minus 2 is greater than 4. Isn't that true? This becomes 5. 5 is greater than 4. That is true, right? It is true. So we were right to reverse the inequality sign. But let us just suppose we didn't, let me erase all of this. Let us suppose we didn't do that. And down here, we didn't reverse the inequality sign, right? Let's go back here. Let's say we didn't do it. And we left the sign like this, right? So x will now be greater than minus 1, right? Let's just say we didn't reverse the sign. Look at what happens. So if x is greater than 1, then x could be 0, right? Let's use 0. Let's use x equals 0. If you were to put that in this inequality here, you get 3 minus 0 is greater than 4. So this is saying 3 is greater than 4. Is that correct? 3 is greater than 4?
No.
No. So we have to reverse this inequality sign. You see? Or else the arithmetic would mess us up. It wouldn't give us the right solution to the inequality. Right? So that's the only exception there. Is that clear?
Yes, sir. That's it.
Good. All right. What we do, we take a few minutes break. Take a 15 minutes. Now it's 6:15. We come back at 6:30. And then we'll take some time and do a little bit on, I think we started factorization the last day. We'll do a little harder ones now, right? We'll do a little harder ones. And then we'll use our knowledge of factorization to solve what we call quadratic equations, right? So we'll take a pause here, take a 15 minutes break, and we come back 6:30 and go again. Good. So let's use the remaining time to talk a little about factorization. I did introduce this to you a few days ago. But what we want to talk about in particular is the factorization of what we call quadratics. Quadratic. Let's start with expressions and then we'll go to equations just now, right? You want to talk about factorization of, maybe I can make it one big heading, of quadratic expression. Let's talk about what is a quadratic expression, first of all. Let me give you an example. X plus 1 times x plus 2. Let's go with that. This is a quadratic expression, right? This is what you call a binomial. This is what you call a binomial. Binomial. And binomial means it's an algebraic expression with two terms, right? Bi means two, right? So that's a binomial. And this 2 is a binomial, right? This 2 is a, okay, what am I saying? That's a binomial as well. So these are two binomials. So when you multiply two binomial, you get a quadratic, right? How do we multiply them? So this is what you do. Multiply, all right. Let me not show you the shortcut. I want to show you what you really do. You multiply everything here by x, right? So you got x times x plus 1 plus 2 times x plus 1, right? So it's like you're multiplying everything here by each of these here, right? So this is what happens. X by x, you get x squared. X by 1, you get x. Come over here now. Positive 2 by x, you get 2x. 2 by this one gives you 2. So that's why they call it a quadratic. There are 4 terms here, you see? 4 terms. Binomial by a binomial, or the product of two binomials, give you a quadratic, right? An expression with 4 terms inside. But you can see that this can be simplified to be x squared plus 3x plus 2, right? Do you understand what is a quadratic? It's a product of two binomials. Good. So what we want to do really is to take this. How do we take this? How do we take this expression, right? And factorize it so that it becomes that. What we did here, we took this and we multiply it and simplify and get this. But how can we do the reverse? How can we do the reverse? Well, the way we multiply to get this is important because it can lead us. It can lead us in the direction of how to factorize, right? So look at what happens here. I just want you to see something. Do you see that, okay, all right, this x squared, it's there. This 2, it's there. But you notice this 3? This 3x? Do you see like it's broken up into 2 parts here, x and 2x? So 3x can be written as these 2 parts, x and 2x, right? Now, there's a reason why you write it that way. Notice 1 and 2, right? The 1 in front here and the 2 in front here, right? We don't normally write 1, but I'll write the 1 here. These two numbers are chosen in a special way. They are chosen that when you add them, you get 3. And when you multiply them, you get 2. This number, the end here. Right? Or really, you get the number in front here multiplied by the number at the end here. And in this case, this is 1 by 2. Right? So you're looking for two numbers really that when you add them, you get 3. And when you multiply them, you get 1 by 2, which is 2. And the two numbers are 1 and 2. When you add them, you get 3. When you multiply them, you get 2. right? So you take this 3x and you split it into two terms, x plus 2x. Our next step is to group them up now. So I kind of group them up. Let me see from here. You write it on top here. You group them up like this. X squared plus x plus 2x plus 2, right? And next now you continue to factorize these expressions here, right? Look for the highest common factor here. What is it? It's x. Well, I actually did it here, right? X by x plus 1, right? You take out x from there, you get x into x plus 1. Common factor here, 2. Take out 2, you put it out here, you get 2 by x plus 1, right? That's the same thing. Now you apply the distributive law one more time. You're seeing that this and this is common, and that's why we pull it to the front. Times x plus 2 in another bracket. You see? So the way we multiply the two binomial expressions to get the quadratic helps us to factorize quadratic expressions. We're going to do more examples. I just wanted to illustrate something to you. So we're going to do that, right? Let's do that. So let's say we want to factorize. Let's get x squared plus 5x plus 6. Look at this. I want to factorize that, right? How do we do that? How? So as I said, we look for two numbers. Look for two numbers. P and Q, maybe you want to call them, such that P plus Q must be equal to 5, and P times Q must be equal to this 1 by the 6, right? 1 by 6, which is 6. And you can quickly see the numbers, right? P can be 2, Q can be 3. You all agree? Good.
Yes, sir.
So what we're going to do now, we're going to take this expression, we're going to write it back, right? And no, we're not going to use 5x. We're going to use the numbers 2 and 3, and this is what we're going to do. X squared plus, you can go with 2x plus 3x, same 5x, but you're splitting it into two parts, plus 6, right? So now, take it up a little more. We're going to group these two together. X squared plus 2x, put them together. Right? And we can now factorize further. So let's take out x here. You get x plus 2. Take out 3 there. 3 seems to be the common factor. We get x plus 2. Now we also see here that these two brackets are the same, so we can pull them to the front. X plus 2 times x plus 3. And that's it. So we have successfully written x squared plus 5x plus 6 as a product of two factors, x plus 2 and x plus 3. Because that's what factorization is. Writing something as a product of its factors. Follow that one? Let's do another one. Let's try another one. Let's say we have to factorize x squared. Let's go with minus let me go with minus x minus 6. Right? So let's see. Oh, by the way, not all of these quadratic expressions can be factorized, right? So keep that in mind. Good. So we're factorizing that. So again, I said we're looking for two numbers. When we add them, you must get -1. And when you multiply them, you must get this 1 by -6, which is -6. Right? Can you think of two numbers? P and Q. Think of two numbers for me. They must add up to -1, and they must multiply to give you -6. Help me. You can't think of the two? Nobody can think of two numbers? Y'all are hearing me, right? Hello?
Yes, sir.
Yeah, y'all can think of two numbers? Think of two numbers. When you add them, you get -1. And when you multiply them, you get -6. There are only a couple of numbers that will do that. Not hard to think about. If you have to do this by yourself, you'd have to think about it.
Sir, somebody send the numbers in the chat.
Huh? No, tell me, man. I don't want to go and check chat and so now.
Sir, 2 and -3.
Okay, let's try that. So we're going with 2 and -3. And that makes sense. When you add them up, you get -1. When you multiply them, you get -6. So we're going to rewrite this as x squared. I'll go with plus 2x. I'll do this deliberately because I want to show you something. Right? Good. So now we're going to group them up. And I want you to see something, right? Group them up like this. Okay. But here, if you put a minus sign here and you go like this, you have to change this to a plus sign. Right? Because if you remove back this bracket, you will get that. If you don't have a minus, if you have a minus sign here, this minus by that minus will make this plus. So when you do, if you take out this minus sign out of the bracket, you have to change this sign. That's a trick. I'll show you an alternative just now. But let's go with this. So we go with x into x plus 2, minus, you take out 3 now, and you get x plus 2 again. And because you now have that, these two brackets are common. You pull them to the front. And then you go with x minus 3. Right? Down here, if you don't like what I did here and you want to go, all right, let's take this approach. So, sorry, I'm coming from here, right? Here. So you go with x squared plus 2x. And you want to put a plus sign there, no problem. Put minus 3x minus 6 in there, right? So we go like this. Good. So now you take out your x bracket, x plus 2. And down here, the highest common factor you'll use is minus 3 bracket. So minus 3x divided by minus 3 will give you positive x. Minus 6 divided by minus 3 will give you positive 2, right? And then you do the same last step, x plus 2, and then you put x minus 3 in this bracket. Then you're done. So this one got a little twist to it. Follow so far? Let's
This one a
try.
little more complex, but
Yeah,
all right.
yeah, yeah. It takes some time for you to figure it out. Huh? Let's go with one very similar to this one. Maybe I'll go with this. 2x squared minus x minus 3. Look at this one. You're asked to factorize this one, right? So let's see. So we're looking for two numbers, call them P and Q. When you add them up, you must get minus 1. And when you multiply them, PQ, again, there must be 2 by minus 3, which is minus 6. This is a no-brainer, right? You know what I should have done? I should have switched the 2 and the 3. I should have put the 2 at the back and the 3 in front. All right, I'll give it away. Yeah. So the two numbers are 2 and 3, right? P equal 2, Q equal minus 3, right? This is a no-brainer. I should have switched it around. And yeah, all right, leave it like that. So we now have 2x squared. And if you are smart, right, with experience, you'll see that this will avoid that negative sign you will have to deal with just now. So this is what I'll do. I'll take the minus 3 and put minus 3x plus 2x minus 3, right? So now I can group safely because there's a plus sign here. Right? Put that there. Plus 2x minus 3, right? Come up here now. Come up here. So here, what is common? X, right? So you get 2x minus 3, okay? What's common here? Just 1 times 2x minus 3. So this bracket and this bracket is common, so you can bring it in front. Times x plus 1, right? That's your product there. That's your factorization here. The two factors. 2x minus 3 by x plus 1. Follow so far? Let's do a last
Yes, sir.
one. Let's do a last one. All right, let's say you have one that involves factorize. Let's go with we go with 6 plus no, let me go with 1 second. I'm making this up on the fly, right? Minus x squared. Look at this one. Of course, this can be written as, and a lot of students would rather do this. They take minus x squared minus x plus 6, right? That's what they do. But I leave it as it is. So we're looking for two numbers, P plus Q must be equal to minus 1 And PQ must be equal to the minus 1 in front here multiplied by 6, which is minus 6, right? Again, you know the two numbers, right? P and Q. P is minus 3, Q is 2, right? So we write back this here. 6 minus 3x plus 2x minus x squared, right? Same thing. Then we group them up. Right? And then we factorize here, right? So we go with 3 bracket, because 3 is a common factor here. 2 minus x plus, what is common here? X. 2 minus x. And these two are common, so we put them in front. 2 minus x times, instead of writing 3 plus x, some people write x plus 3, right? No problem. Can do that. Same thing. So that's a little bit of introduction to factorization, right? They have some other factorization, some shortcuts and so on. I'm not going to get into too much of it. Let me just touch on it and show you. There's something called factorization by difference of squares. It's a kind of shortcut. Like if you see something, right, you're asked to factorize something like this. Factorize x squared minus 4. Right? There is a thing that says that if you have a squared minus b squared, then this is equals to a plus b, a minus b, right? And you can see that this resembles that. X squared minus 4 is the same as x squared minus 2 squared, which is equal to x plus 2 times x minus 2. See that? That's a difference of squares. I'm not going to go into too many of them. I just wanted to introduce you to factorization a little, right? You'll see a lot of this different places. What I want to go, and this is the last thing we'll touch on, is how do you use factorization, right, to solve quadratic equations by factorization. How do we do that, right? How do we do that? Good. So let's say, all right, we have to solve x squared plus 5x plus 6 equals 0. And that's something that is necessary. Your quadratic equation must be equal to 0, or else the method I'm going to show you doesn't work, right? So you have to make the equation equal to 0. Good. So when we factorize, I'm going to skip the step as to how we factorize. When you factorize this, you get x plus 2 times x plus 3 equals 0. You get that. Now, there is a thing in mathematics to say that if two numbers, I'm coming back to the equation just, if two numbers a, b equal 0, then either a equals 0 or b equals 0. Think about it. If two numbers multiply to give you 0, one of them is 0, right? One or the other is 0, right? Good. We're going to use that same principle here. If these two brackets, this is like the A, this is like the B. If these two multiply to be 0, then either x plus 2 equals 0, and if that is so, x is equals to minus 2, or x plus 3 equals 0, which implies that x equals minus 3. So your solution then, I'll write it here. Solution, x equal minus 2 or minus 3. Right? And that's a simple way that you use factorization to solve quadratic equations. Very, very simple. Once you get it factorized, you put each bracket in turn equal to 0. Right? So you see, x plus 2, I take this bracket, put it equal 0. If x plus 2 equals 0, I take the 2 over there, and you get x equal minus 2. Or you take the other bracket now, x plus 3, I put it equal 0. If that is equal 0, I take this over here, you get x equal minus 3. So either x equal minus 2 or x equal minus 3. And that's how you use factorization to solve quadratic equation. Is that difficult to grasp? Okay, good. However, for quadratic equations that can't be factorized, there are some other methods, such as there's a formula. There's a formula. Maybe I can show you that formula, as I can very well have you. Let's take that same. Let's take that same equation. Solve x squared plus 5x plus 6, right? There's a formula that x equal, and I'm not going to show you how to solve this one. I'll leave you to try it at home, right? X equal minus b plus or minus the root of, I should say this, let me rephrase this whole thing. Let me rephrase this whole thing. Let me rephrase it. If ax squared plus bx plus c equals 0, then x equal minus b plus or minus b squared minus 4ac all over 2a, right? So there's a formula. What I'm going to ask you to try to do, you just got the answer to this one. I want you to solve x squared plus 5x plus 6 equals 0 using this formula, right? You know your answer has to be x equal minus 2 or minus 3, right? I want you to try this at home between now and Friday, right? Try that formula. And then there's a harder method called completing the square. There is even another method, right? But we're not going to get into that in the course, right? We're going to leave that for another course. Well, I want you to try this, substituting in this formula, see, right? Good. So what we're going to do, we're going to pause there. Let me stop the recording.